Hi everybody, this is Mr. Folly, and welcome to podcast 9.2, where the slides change for no reason, and chemistry is learned by all. So we're going to talk about STP again. 22.4 liters is 1 mole at STP, and gas stoich with ice diagrams. So let's take a look at that. Oop, oop, oop. Now you can change sides. Come on, there we go. The standard. We have a comparison temperature and pressure. 273 K, this is 0 degrees Celsius, is the standard temperature. 1 atmosphere, this is 760 millimeters of mercury, is the standard pressure. So if we say something is at STP, that means you need to have 273 K. We always do our calculations in kelvins because it is directly proportional to particle motion. And 1 atmosphere, which is the pressure. All right. When we are at STP, the volume of 1 mole of any gas is 22.4 liters. This is what you need to know. That seems really weird, though. Okay. Gas particles are very, very, very small. This means their sizes are the same, and I put 0, and really close to 0. Okay. So if 1 mole of any gas is 22.4, what is the volume of 1 mole of H2? 22.4 liters. What is the volume of 1 mole of CO2? 22.4. So let's do some math with it. Assuming all volume measurements are made at STP, what will the volume in liters of oxygen required for the complete combustion of 0.350 liters of propane? So let's do that first. So what will be the volume in liters of oxygen? So what I want to get here is get the volume of oxygen. Okay. Now it tells me I have 0.350. Get back here. I have 0.350 liters of propane, which is C3H8 times dividing bar. And then remember we learned that there's 22.4 liters of stuff in 1 mole of stuff. So 0.35 divided by 22.4. Oops, my calculator's going crazy. 0.35 divided by 22.4 is 0.0156 moles. Remember, these have to equal each other. 1 mole equals 22.4 liters. All right, so now I have to do an ice diagram for this to figure out the liters of oxygen required. So if I have 0.0156, get back here. Oh, it's going to do this again. And I have 5 moles of O2. What I have to do, it takes 5 moles of O2 for every 1 mole of propane. So I'm going to take 0.0156 times 5. Whoops, I'm going to put my 0.0156 here. And this actually should be the change line. This is going to be minus 0.0156. And this is how I figured out. So that's going to be 5 times 0.0156 is really 0.078 moles, which goes up there. And that's my answer for moles of oxygen. Now I have to convert moles to liter. 0.078 moles of oxygen to liters. Remember, 1 mole is 22.4 liters. So 0.078 times 22.4 is 1.75 liters of, that's not liters. Yep, liters of O2. Okay. Part B says, what will the volume of carbon dioxide be produced in the reaction? So the volume of carbon dioxide, this starts out at 0, is going to be based on your mole ratio. Again, 3 and 1. And remember, this was 0.0156. So 3 times 0.0156 is 0.0468 moles of CO2. So now I just have to convert that into liters. 0.0468 moles of CO2 times 22.4 liters in 1 mole. 0.0468 times 22.4 is 1.05 liters. All right. Well, I hope that goes away. Then I've got calcium carbonate. It turns into calcium oxide plus CO2. This reaction is used in wastewater treatment plants. So thankful for that one. How many grams of calcium carbonate must be decomposed? So I want grams of calcium carbonate must be decomposed to produce 5 liters of carbon dioxide at STP. So the first thing I'm going to do is I'm going to take 5.00 liters of CO2 and I'm going to convert that into moles. So 5 divided by 22.4. Actually, you can't be here because you're watching videos last time. Sorry. So that's moles of CO2. And then, so now what I have to do is figure out how many grams of calcium carbonate. So I've got CaCO3 turns into CaO plus CO2, and that's 0.223 moles. So if this is 0.223 moles, I have coefficients here which are the same. So if my coefficients are the same, it means I would need 0.223 moles of CaCO3. And then I need to change that into grams. So I need to go to the periodic table and add up calcium. 40.06 plus 12.01 plus 48 is 100.07. So 0.223 times 100. There we go. 0.223 times 100.07 is 22.3 grams of CaCO3. So, got one more, last one. Tungsten in metals used in light bulb filaments is produced industrially by the following reaction of tungsten oxide with hydrogen. How many liters of hydrogen at 35 degrees Celsius and 0.980 are needed to react completely with 825 grams of tungsten oxide? So what I'm going to do is figure out how many liters it's going to be in, so I have WO3 plus 3H2. It's going to turn into W plus 2H2O. So what I'm going to do is figure out how many liters it's going to be at STP. Okay? So if I start with 875 grams of tungsten oxide, and I'm going to have 1 mole of WO3, and then grams of WO3, I've got to find the molar mass of W, 183.84. 183.84 plus 3 oxygens is 48, 231.84. So, whoops. 875 divided by 231.84 is going to be 3.77 moles. Okay. Now I got to rewrite this because I got to do my ice diagram again. And then I found out 3.77 moles of WO3. I want to know how many liters of hydrogen this would be. So I need to figure out this right here. So if this is minus 3.77, this is going to be minus 3 over 1 times 3.77. And that's going to be 11.3 moles of H2. Is that what it was? Yeah, H2. So now I need to change this at a new temperature. So what I need to do is, once I know this is how many moles of this I have, I want to convert this into liters. So 1 mole of hydrogen is going to be 22.4 liters of hydrogen. And that's going to give me 253.6 liters of hydrogen. And if I want to figure out how many liters that's going to be at that pressure, I have to do P1V1 over T1 equals P2V2 over T2. So my original pressure is going to be 1. I'm at STP. My original volume is 253.6. And my original temperature is STP 273. Equals my new pressure is 0.98. My new volume is what I'm solving for. And my new temperature is 273. So I'm getting my pressure, my volume, 273 plus 35, which is 308. So now to solve for V, I'm going to have to go back to the slide, and V is going to be 253.6 times 308 divided by 273 divided by 0.98, and I'll get my answer. 253.6 times 308 divided by 273 divided by 0.98 is 291 liters of hydrogen. So we'll go back to that. 291 liters of hydrogen. Sorry, the screen's going wacky. All right, review. Know your gas formulas. That's the P, V, over T, etc. And moles and pressures are proportional. So that's it. Toodles.